Hi there, my name is Mantas Nipsavičius, and at the moment I will want to share that I'm making some parts, and maybe you will find some interesting aspects how I made it. So I will show you my setup. At the moment I'm using Tormach MGCNC 1100 mil, and I will show you the final parts that I am doing right now. It's a holder for PCB, and it will be used for repair of smartphones, maybe other devices. So I have this order right now and I'm making it. The main problem with this part is that I'll show you one finished part. It is the holes that are drilled pretty deep. I'm searching for that part that has these holes. Oh yeah, here it goes. Yeah, this one. So you can see there are two holes at the end of this part, yeah, and they are going right this deep. So it's quite deep, and if you are drilling just from the top to this point, the drill tends to shift in some direction and you lose the accuracy of this bottom hole that is right here. So I think this part has this complex side. It's not very complex, but you have to make this a little bit carefully. Okay, so I now will show you how this part is done on the mill. I will flip the camera just to show. So you can see I mounted this part in vise. I'm using soft jaws just to make sure that everything's machined and I have no damage to vise jaws. Yeah, so at the moment I will run this code and we will see what happens. So I put this protective sheet cover. Okay, so we will start machining. First operation is this 10mm end mill. It will do now I am doing this part. I'm milling for the length, the correct length, yeah, and one pass is the rough pass and another pass is for finishing. start doing the pocket with 2D adaptive pass. First the helical entry and now to the adaptive machining. Now I will change the tool to 6mm end mill, and we'll do also adaptive flaring. Okay, we'll have to coolant modify a little bit. Now we'll make 2 more pockets with this smaller end mill. problem that chip operation is quite bad. It's not enough pressure from the standard coolant setup, so it's always a little headache for me, and I cannot leave the machine running and be confident that all chips are clear, but it's always a problem. Another pocket. I'm doing this like 5000 RPM, and cutting feed rate is something like 1000 millimeter per minute, so it's about, I would say, 40 inch per minute. Well, this operation is finished. Now we next operation will drill. So I will center the hole, and then I will drill them. Using support drill of 10 millimeters in diameter. Now it will change to 3.3 drill. 4mm end mill to finish corners and side pockets. It's a little bit annoying thing because I'm using for this part Fusion 360 and it's like I'm using 2D adaptive, and after that there are no, in my opinion, there are no good strategy to finish with smaller end mill. So you don't have any like 2D adaptive rest machining, and it's a little workaround that I found that you can use I think 2D pocket, and then you can select rest machining, and after that you have to play a little bit with corner radius parameter in rest machining, because if you leave it like the same like in your 2D adaptive operation, then it will make a lot of unnecessary haircuts. So for me, I think it's not as good as I would say. I'm using also solid cam, so there I'm machining operation, and also you can choose after that I'm machining finish operation, and it works perfectly in that case. Doing multiple corner milling, and then goes for the finish pass. After this operation, next one will be chamfering all the pockets and the outside perimeter of the part. So this is chamfer mill. Splashing the coolant on the camera. Outside perimeter of the part. stop it, and the part will be finished. And the part is finished. I will remove it. Okay, so here's the finished part. Not exactly finished, but this setup is finished. Now we have to do another operation like this. We will mount the part, and when we mount the part vertically, we will drill these holes that will come here and here, and also to land here on this surface and also on this surface. Yeah. So okay, we will do this next. Next operation will be drilling 4.2 millimeters hole. So next I will use center drill, a long center drill. Like this one. It's 4 millimeters in diameter, and the tip is 1 millimeter. So, okay, let's see how it goes. It spots this hole. Now another one. Okay, so next I will use a long drill. So this is the drill that I will using for this operation. Okay. And I tweaked a little bit this drilling operation. At first it goes deep enough until it reaches a hole with low RPM, and then it hits 1000 RPM when it starts drilling. So let's see how it goes. So now 250 RPM, then it increases up to 1000 RPM, then again stop with it, now it goes deep enough, and again 1000 RPM, and good. Okay, this is done because it vibrates at a higher RPM. Okay, now it's done.